Hey everybody, and welcome to chapter number 12. We're talking about decision making, or as the textbook refers to this one, judgment and reasoning. But I feel like almost every time this book gets published, it's kind of renamed something different. It used to be decision making and reasoning, and then judgment, decision making and reasoning, and then now just judgment and reasoning. So I don't know if that actually matters, but we're talking about decision making today. We are skipping over chapter number 11, and the reason for that is because I hate chapter number 11 and it's stupid. But no, actually the reason why is because some of those ideas, it's a chapter about visual knowledge. And a lot of that, or some of that information, we've already covered in other chapters, but also that chapter is so scattershot and it covers such a wide variety of different topics that it doesn't really feel unified. And so for that reason, I'm looking at the course syllabus, I'm looking at how much time we have to be able to cover info, and that's just the chapter that I decided to cut. Yeah, so I hope you're not too bummed about that. But if you are, then you can, you already bought the textbook. You can check it out if you want to. So let's talk about chapter 12, though. This is about decision making, and as I've kind of talked about with other chapters that we've discussed this semester, this is a whole field. Decision making is, and judgment and reasoning. So much so that where I went to grad school, our undergraduate program, part of the college, had a decision-making class, and it was kind of offered like once a year. Not like a capstone class, but just, an elective that you could take. Like you could go to conferences that are just dedicated to research on decision making. So it's kind of like psycholinguistics in that way. It's kind of like memory in that way, where this is a, kind of a fraction of the class that we're teaching or that we're doing this semester. But if we wanted to, we could turn it into an entire course, because there's so much research out there and so much that we know about decision making that's interesting and useful to learn. So we're just going to kind of like look at it as kind of like we're going to play the hits, basically, for this chapter. So let's get into it. Sorry, let me set my timer so I know where we are on time as we go through this. So we're going to be talking about decision making, and one of the things that I'm interested in is why is it that folks are bad at stats? And I say this as somebody who started out bad at stats. I teach stats now, and I like stats, and I'm okay at it. I wouldn't call myself great at it, and the reason why is because I'm married to somebody who I think is great at stats, and I know I'm not as good as she is at stats, so I'm good at stats, but I'm not great. But I reckon, as somebody who teaches stats, I hear all the time about students saying that class is hard, and that they don't understand it, and they have a hard time wrapping their head around it, and there's a good reason for why that is, so we're going to be talking about that today. And we're also going to be looking at lots of different versions of heuristics, which are kind of like mental shortcuts that we use in order to make decisions. And then we'll kind of wrap up the final part of this chapter by talking about logic and reasoning and why we are bad at logic as well. Because if you've taken a philosophy course, some people... And it's, honestly, logic is a lot like math, where you just have some people who will tell you, like, I've never been good at math, I've never been good at logic. And you'll have some people who say, like, oh, logic just comes naturally to me, and math just comes naturally to me. So we'll talk about those things today. Let's get into it. The video that I have for us today is actually directly tied into kind of the opening part of the chapter, so I would recommend checking it out, but I don't know if it's going to be an important, mandatory watch, because we're going to be kind of talking about confirmation bias. But to skip ahead really quickly to look at this next slide before we talk about confirmation bias, here are some of the other recommended videos for you. So this one right here, the one about Veritasium hypothesis testing, I'll talk about that one specifically. So if you watch any of these, I think that's a good one to watch the first half of, because we'll be doing that in this video. But the other ones are also really interesting. So Daniel Kahneman is a guy who literally wrote the book on decision making, and is kind of, like if the first name that pops in your head when you think about behaviorism is B.F. Skinner, and developmental psychology is Piaget, and for psychoanalysis is Freud, I feel like Daniel Kahneman is that name for decision making. He's kind of the guy for that. So we'll talk about some of his work today. We'll talk about a lot of his work today, actually. Here's a video looking at some other cognitive biases and heuristics. This is kind of a fun one, in case you get bored. And then this last one about Bayesian probability. Bayesian probability is an area that I wish that we had time to go into, but sadly we don't. Our textbook doesn't really talk about it that much anymore, which is why I don't talk about it anymore. But as I was finalizing these slides, I cut out a big section on Bayesian probability. So if you're interested in that, and it's kind of like an alternative to the stats that you learn in your undergrad stats class. So if you took stats with me, you learned about frequentist stats. This is a totally different branch of statistics that we generally don't talk about at the undergraduate level, but it's really interesting to me. And if you're intrigued by that, check it out. All right, so let's talk about confirmation bias. Okay, so confirmation bias is the idea that, and it's a bias that everyone has. It's just kind of the way that the human brain is wired. It's the idea that when we have a notion or we have a hypothesis or we have an understanding about how behavior works or how the world works or how politics works, that we will look for evidence that supports our beliefs more than evidence that would refute our beliefs. And furthermore, that the evidence that we see that supports our beliefs, we are going to weigh more heavily in our decision making than evidence that refutes that. So, for example, if I were to tell you that Twin Peaks is my favorite TV show of all time, I might look at other lists of best TV shows of all time, and then the ones that mention Twin Peaks, I'm going to bookmark and I'm going to be like, yeah, they get it. This is a good website because they agree with me. Like, that's what I expected to find, and I found it there, so this must be a good list, right? And so that's going to further confirm my beliefs, but I'm also going to weigh evidence less if it refutes my belief. So if I find a list of top 10 TV shows of all time and I don't find Twin Peaks on there, I'm going to be like, oh man, this website's garbage. They don't even have Twin Peaks on here, right? So that is a very trivial example of confirmation bias. But confirmation bias is, and I don't have evidence to back this up, I don't have raw data to back this up, but I feel like so many of the things that we all agree upon are kind of like the bad parts of society that have happened because of social media and because of, the internet and stuff like that. I feel like a lot of it comes down to confirmation bias, because with the internet, you have confirmation bias 24/7, right? Whenever you go onto any kind of social media platform, that platform is going to show you things that it thinks that you will be interested in or that you will agree with, so that you will further engage with it. And so your understanding of the world will be much more in line with what you already thought. It's not going to challenge you. It's not interested in challenging you, because if it challenges you, you're going to want to go to a different platform. You're going to want to go somewhere else that confirms your own beliefs. So let's talk more about that. And like I said, I don't have data to say like, the reason why everybody's unhappy today is because of confirmation bias. But I think once you learn about it, you'll see how confirmation bias has worked its ways into so many facets of our lives. So you can maybe easily see how this is related to hypothesis testing and research methods. If you've taken research methods, you may remember that testing a hypothesis is kind of weird, because you can't really what you're not supposed to do in research. You're not supposed to come up with a hypothesis and then do everything that you can to prove that hypothesis correct, right? Because if you do that, you're going to be likely to not look at confounds or alternative explanations. Instead, what we teach in research methods is that you should try to disconfirm your hypothesis. You're trying to refute your hypothesis so that by the time you get down to the very end, what you would say is like, look, we tried everything. The only explanation that works is this one explanation. And that's why whenever you take stats, we talk about rejecting the null hypothesis or failing to reject the null hypothesis. And if you don't know what I'm talking about here, then that's okay. You'll experience it next semester or whatever whenever you take stats. But when we talk about confirmation bias in research or in science, that we should be careful about this, that if we think behavior happens because of X, Y, and Z, we shouldn't just look for the one that we think is going to confirm our hypothesis. We should look at all the explanations and try to test them individually to see which one works best. So let's talk about a quick example of confirmation bias. I don't have a coin in front of me, but you could do this on your own if you want to. if you flip a coin 6 times, there is a possibility that that the 6 times you do it, it lands on heads. So you flip a coin, and 6 times it lands on heads. All right, now when you're going to flip a coin one more time, before you look at it, what do you think it's going to land on? Do you think it's going to land on heads, or do you think it's going to land on tails? Most times whenever I mention this to folks, they will mention that, oh, it must be a trick coin, or that this is impossible. It's not impossible. You can do this. If you were to flip a coin 100 times, there's a strong likelihood that you're going to get a run of 6 heads or 6 tails in one, somewhere along those 100 flips that they happen in a row. So how likely is it to land on heads whenever you do this? People get a little bit confused here, because depending on who you ask, sometimes people will say, oh wait, it is going to land on heads again. Why? Because, oh, it's a trick coin, and it's landed on head these other 6 times, so it's probably going to do it again. But a lot of folks, and I would say probably the most folks would say, is going to land on tails. It's more likely to land on tails now. Why is it more likely to land on tails? Well, because the 6 previous times to land on heads is very unlikely for it to land on heads 7 times, right? So it's more likely to land on tails. But the truth of the matter is that it's actually likely to land on heads or tails evenly. It's a 50% chance evenly. We don't like to hear that, though. Most people are still like, no, that's not how it works. You just got 6, and it's really unlikely to be 7, so therefore it's likely to be tails, don't you think? It's actually likely to be 50-50%, that there's not going to be one or the other. And this is what I mean about how humans are bad at assessing probabilities and statistics. So the first half of this lecture is, why is this? Why is it that we are likely to think that tails is likely to end up next? In order to do that, we need to talk about some of the biases that our cognition allows us, or that it pushes us towards. So let's continue talking about confirmation bias. So with confirmation bias, what you have here is where you are responsive to evidence that confirms your own beliefs, and you're going to be less likely, you're going to play down the evidence that disconfirms your own beliefs. And you can probably think of a million examples of, if you're at all interested in politics, you can find a million examples of this no matter what party you're interested in. You're going to find examples where you thought something was going to happen, and your friends thought that something was going to happen, and it didn't happen, and you were surprised. Why were you surprised? Because all the news articles you read said this one thing was going to happen, and it didn't happen. And that's an example of confirmation bias, that you were looking at the news sources that reflect your own kind of personal beliefs, and so you feel very strongly this one event's going to happen. But you may not have paid attention to a lot of the evidence that said that wasn't going to happen, right? Okay, so this leads to a polarization in our beliefs, and to give you kind of a non-political, because I'm not interested in politics, if you can Google examples of confirmation bias in politics if you want to. You're going to find a bunch, but I don't want to alienate anybody in this class, so I'm going to go with an example of movie reviews. So y'all know that I like movies a lot. I talk about it all the time. So let's say that the newest Marvel movie has come out, and I'm not a big fan of Marvel anymore. My best friend he loves Marvel, right? So if I think that the movie stank and was not very good, and he says that it is very good, what do? How do we resolve that argument? Because we both have phones in our pockets, we're probably going to do what you would do, which is that you take out your phone and you're going to search for examples that would prove the other person wrong. So I think the movie was, here in this example that I wrote out, I say that it's good. My friend thinks that was bad. So I'm just going to change my position here. My friend thinks that the Marvel movie was bad. I think the Marvel movie was good. So who is right? I'm going to go in and I'm going to Google, Captain America #7. Good reviews. And my other friend's going to say Captain America #7 box office failure. And we're both going to find lots of examples of the internet feeding us articles of, Captain America box office success, good reviews, critics love it. And then my friend's going to get totally different search outcomes, right? He's going to get examples where people are talking about the box office failures. And both of us are not going to actually persuade the other person, right? Because we both found information that confirms our own beliefs, And I'm not going to think very much of his evidence, right? Because I have my own evidence, and I like my evidence. It supports what I believe. He has evidence that supports what he believes, and so we're just going to dig our heels in, and we're just going to feel even more passionately about this one thing that doesn't really make that much of a difference. That's not really that important. But you can imagine how whenever people start talking about immigration or abortion or criminal justice reform or housing or whatever, that people are going to look at their own evidence and dig their heels in and say, like, no, this is the solution, or no, this is the solution, because we only tend to look for things that confirm what we believe. So that's one example of a bias that can change and alter the way that we make decisions. In this case, this is irrational, right? If we were rational beings, then we would look at the evidence and we would analyze it skeptically, but with no bias, and then we would accept whatever the evidence told us if it was good evidence, right? In a perfect world. We like to think that we might behave like that, but that's not how human beings behave. And so this chapter, a good portion of this chapter, is about why is it that humans make bad decisions when we should be making good decisions. All right, so this is the video that I was referring to, where you can look at this guy. His YouTube channel is called Veritasium. I like his channel a lot. It's this cool science education channel that has a lot of really cool physics and psychology and engineering and stuff like that. So kind of like Vsauce, if you know Vsauce, but with fewer followers. This video, I recommend it because the book even talks a little bit about this idea of confirmation bias, but you can see how it works here in the first half of this video. You don't have to watch the second half, but it's kind of a fun video. I showed this in my research methods class too. All right, so the goal of any science, as you may remember from your Psych 101 years, is that any science seeks to do three things: to describe what it is studying, to predict what it is studying, and to explain what it is studying. So if we're thinking about this with human behavior, we need to be able to describe human behavior. I feel like we're pretty good at that. We can explain human behavior. We're okay at that. And then we need to be able to predict human behavior. And that is, depending on who you're asking, is kind of, I don't know, maybe we can, maybe we can't predict human behavior. I think that we're actually pretty good at predicting human behavior. It's just that we typically fail to account for the non-rational ways that humans make decisions. So we don't always behave rationally, right? And you know this because of procrastination, right? Procrastination is a great example of how humans don't behave rationally. Like, I have a bad habit of procrastinating, so I may stay up late and then work on something when I know I should have done it 3 days earlier. I would have been in a better mood. I wouldn't feel as cranky. I would have much more time to work on it. It would have been a great idea. So why didn't I do it, right? That would be an irrational thing to wait more to do it. So that's just one example, but we're going to look at lots of examples of why we maybe choose poorly on these things. So within cognitive psychology, there are kind of two avenues to look at. One is what happens when we make rational decisions, and why do we make rational decisions, which is kind of boring. And then we can look at what kind of decisions do we make when we are acting irrationally, and why. And this is probably where we are going to be focusing a lot of our attention in this chapter. But I do want to say that humans are pretty good at making decisions, right? It's just that by studying the ways in which decision-making goes wrong can tell us a lot about normal, quote-unquote, normal, rational decision-making. I think of this a lot like our chapters on memory. So in our chapters on memory, we talked about amnesia for quite a while, right? And we talked about false memories, and we talked about what happens when memory goes bad. But all of that was really just to kind of emphasize exactly how normal memory works. What is memory like when we don't have amnesia, right? So if it sounds like I'm really down on humanity this chapter more so than usual, it's mostly just because I want to kind of look at the ways in which people make wrong decisions so that we can better understand why we choose to do the things that we do. So we're going to be looking at descriptive models in that way. Descriptive models are how people actually behave, and prescriptive models are how people should behave if they are acting rationally. If you are interested in further reading on these topics, here are 3 books that I recommend to varying degrees. I mentioned at the very beginning of the semester that I used to assign this textbook right here, and actually, hold on one second, I'll be right back. That this book, Thinking Fast and Slow, is a great book, very, well, I was going to say easy to read, but it's for a broad audience. It's not just for psych grad students. It doesn't really feel like a textbook. It's just kind of a nonfiction book, you know. But it's like 500 pages, and people generally, because I used to assign this in my cognitive psych class, people didn't like that. They didn't like an additional 400 to 500 pages to read. But we're going to be talking a lot about Daniel Kahneman in this chapter. So he's a super important figure in psychology. As you can see here, he won the Nobel Prize in economics. And I think that this is a great book if you are interested in learning more about this stuff. This is a great scholarly way to kind of go in. You know, he doesn't talk down to you like you're an idiot. He doesn't oversimplify things. He gives you cool examples and little puzzles to kind of solve. It's a good book. The reason why I said I would be right back is because he actually has another book called Noise, which is also really good. Not as good, I would say, but very interesting. He's, that's Daniel Kahneman. These other 2 books, these are not actually by psychologists in the same way. People think of Malcolm Gladwell, if you've heard that guy before, people think of him as a psychologist. He's actually a journalist. He's got like a bachelor's degree in psychology, so whenever you graduate from Westfield, you'll be just as much a psychologist as Malcolm Gladwell is. But he writes a lot of books about popular psychology, and this one is about the power of instinctual thinking. So thinking with your gut, like going with your first guess. Some of you, I would recommend this too, because you tell me on quizzes or exams like, oh, I didn't go with my gut, right? And you regret not going with your gut because the gut was the right answer. This book talks a lot about that. And then finally we have Nate Silver, who is, he's a statistician, and this book is all about making predictions using Bayesian probabilities. So it's good. I think I would, in terms of like which ones would I recommend for you, I would say this one's number 1, this one's number 2, and then this one's number 3. And then if you finish number 3 and you still want more to read, let me know, because I got a lot of books I'd be happy to recommend you for further reading on this stuff. So let's talk about Daniel Kahneman here. So Kahneman, he is popular for a lot of, or influential for a lot of reasons related to decision making, and I would say maybe his most influential is about the dual process of thinking. And even though this is often attributed to Daniel Kahneman and Amos Tversky, who was his collaborator for a number of years, it actually dates back quite a while. So William James, who wrote the first American textbook in psychology, he would talk about this in terms of like thinking is 2 parts, that it's associations and classical conditioning, and that it's reasoning, and that those 2 things combined contribute to your ability to think. So, for example, and I'm thinking of this example off the top of my head, let's say that you're driving by McDonald's. If you're like me, I'm driving by McDonald's, and I'm a little bit hungry. My gut instinct is like, oh, I want to pull over to the drive-thru and grab something from McDonald's real quick. I'm going to get a double cheeseburger and some large fries and a cold Coke. Man, that sounds good to think about. McDonald's has got the best fries. So that's going to be one part of my brain. The other part of my brain is going to be like, no, actually, you need to cut back on calories, and this is just the thing that's gotten you into hot water before. This is just easy, available, cheap food, and you should skip it and wait until you get home and have something healthy, right? So those are kind of two separate thoughts. According to William James, that first one is going to be my associations, and then the second one is going to be my reasoning. Petty and Cacioppo in the 80s referred to this as heuristics versus analytics, and then Daniel Kahneman in 2000 really kind of formalized this in terms of intuition and reasoning, and he's going to refer to this as System 1 and System 2. But they all kind of refer to the same thing, that our thought processes have 2 separate streams. One that is fast and instinctual, which is what we have here, and then one that is slow and reason-based, which is what we have here. So let's talk a little bit more about these. System 1 is kind of like your instincts, and so system 1 is going to be that kind of very fast, instinctual kind of gut reaction that you have. These reactions are sometimes based out of associative conditioning. Sometimes they're based out of emotion. And they're not really kind of a rational, conscious process that you are aware of, right? It is something that's, you just feel it, you know. And it's nearly, they use the phrase nearly automatic here, because there are some cognitive processes that are influencing this, but really not that much, so it's nearly automatic. System 2, on the other hand, is the opposite, and Kahneman calls this the lazy system, because it can do good work, but you actually have to kind of wake it up. It's not something that comes to you automatically. So whenever you're driving past McDonald's, the thought that, oh, I should drive home and then have a healthy meal that's fewer calories and more nutritious and probably cheaper, I should wait and do that. That's going to be my second thought, right? Because this system is kind of lazy and it's not going to come to my help unless I kind of provoke it, unless I really try to think about it. And so it's based in logic, it's based in reasoning, but it's also slow and requires a lot of cognitive processing. If you were to think like this all the time, you would get very exhausted because it requires a lot of effort, a lot of mental effort to try to get System 2 to make decisions for you. So a lot of what we're going to be looking at here in this chapter is kind of a battle between these two systems. It's a battle between kind of the instinctual part of our thinking and the more reason-based version of our thinking. So let's take a look at that interplay here as we talk about base rate neglect. Base rate neglect is whenever we ignore the natural rate of occurrences for things when we're making probabilistic judgments. In other words, let's say that, I was about to give away an example. I got plenty of examples. I shouldn't come up with one off the top of my head, but I'm going to do it anyways. So an example of base rate neglect would be like, if you know that everyone has turkey for Thanksgiving, pretty much, except your family typically will have a big cooked ham, right? You might think about it and you're like, well, I know that most people have, turkeys, but there's probably other folks like me who have ham. So I'm going to say that it's maybe, 70% of families have Thanksgiving turkey. And then the other third have something else. That's an example of base rate neglect, where you know that almost everybody traditionally has turkey, but you're taking something else into account that's going to affect your probability here. So you're ignoring the prior probabilities, assuming that you're going to have some kind of information that is going to give you a better answer. And usually that additional information isn't really as helpful as you think. So Kahneman and Tversky, you're going to hear these names a lot this chapter because these are the two most influential guys in the area. They won a Nobel Prize together in economics. That's how influential they were. They got a Nobel Prize for something that wasn't even psychology, because psychology doesn't have its own Nobel Prize. So, and we'll talk more about their stuff a little bit later. Actually, I'm going to tell you about it right now. But Kahneman and Tversky, the reason why they got the Nobel Prize in economics is because a lot of their work shows that economic models are inaccurate because it doesn't truly account for how people behave. Because what they show is that people don't follow economic models. Because if you've taken economics before, you probably know about supply and demand, right? But supply and demand doesn't always work exactly like that. And you can probably think of plenty of examples where you have like thinking about like maybe this isn't a great example, but like I always think about Apple products. They're not like this anymore, but they used to be very, very, very expensive, more expensive than what people could afford. And that would be strange because the demand would also be very high and the supply would be high. So why is the price so high? Because it seems like if the demand is high and the supply is high, that the price should go down, because that's what economic models suggest. But that's actually not what happens with Apple products, right? They sell when they are more expensive than their competitors. So there's something else that we're doing that is not what economists tell us that we're doing. And that's what Kahneman and Tversky did that really kind of helped win them the Nobel Prize. So their early work was in this field of base rate neglect, and they kind of branched out to talk about thinking and heuristics and things like that. So an example of this would be conservatism, and I don't mean the political ideology here, but conservatism in terms of like you're very conservative with your money. For example, like if you're conservative with your money, you may hear about a great investment deal, but you're like, actually, I don't know, I'm kind of careful, and so I don't want to do that. That's an example of you behaving in a way that is irrational. You want to be careful, even though you hear about this really great investment opportunity, so you're going to take your feelings into account and not invest. You're being conservative. So you want to play it safe, even when the chances are good, whenever economists would tell you, actually, you should take this, and we think most people will take this. So that's an example of how we behave irrationally. So let me give you a couple of examples of this. Let's say that in this world that only 2% of people who apply to Westfield actually make it in. But you feel like your child is really brilliant. They are in lots of extracurriculars. They play instruments. They're both in the band and in the football team. Excuse me. And so, and they have a 4.0 GPA or whatever. So what is the likelihood that Westfield accepts that student? Whenever you hear about that, whenever you hear about this person who has all these extracurriculars and they have a really great GPA and stuff like that, we start doing some mental math and we start thinking about like, okay, well, that sounds really impressive. It sounds like they are a better student than the average person. And so for average folks, if it's only going to be 2%, then we're going to say this is actually going to be it's going to be more likely for your kid because they're brilliant. So maybe it's going to be 20% now, or maybe even 50% or something like that. In that case, what we have done is we have taken evidence that we think is going to be helpful, that confirms our own beliefs, and we're going to apply it to this. Even though we don't actually know how it's going to affect the math, we think that it's going to affect the math. But what we should think about is that there's lots of other people who are in this exact same kind of scenario. That their children are also gifted and have all these different kinds of talents or whatever, and so they're also going to be competing for this 2%, right? So that's an example of base rate neglect, where we think our chances might be better because we know something more about the situation, when in fact we should be relying on this base rate, on this 2% baseline. So let me give you another example here. So let's say that you were, and this is a very problematic example, but you'll see why I'm using it. So you are working at a hiring firm, and let's say that you know that 80% of the people who applied for this job are women, and that about half of the people who applied also have their forklift operator license. Okay, so that's what you know about your population. You choose an application of somebody, and you see that they are a forklift operator. So they are going to fall within this 50% range right here, right? So you know that they have a forklift operator license. You read a little bit more, you find that they did not complete high school, they got their GED, and they are currently working at a Stop and Shop warehouse. So what is the likelihood of, and I want you to just make some quick mental numbers, what is the likelihood of this person being left-handed? So make some quick mental math here. What do you think the answer is? What do you think is the likelihood of them coming from a wealthy family? So think about whatever that might be. And then what is the likelihood that this individual is a woman? So go ahead and make that mental math. Okay, so now you have roughly 3 percentages, right? All right. So what are the likelihoods here? So let's take a look at this first one. This first one, some of you chose 50%. And I know why you did, but 50% is not the best answer. Why? Because if we were to look at our classroom and I were to just pick one random person, is it 50% likely they're going to be left-handed or right-handed? No, right? Even, and I talked about this in the language chapter. That's about 15% baseline of somebody being left-handed, right? So the likelihood of this person being left-handed is actually probably going to be about 15%, right? Because that's the natural baseline rate of people who have left-handedness. What about of coming from a wealthy family, right? If we want to, we might try, and a lot of times people will say that it's pretty low on this, which is probably true. It's just overall, it's unlikely that you were born into a wealthy family, right? Because at least in terms of international or even in the U.S., the likelihood of being born in a wealthy family is quite low, right? Most folks are either working class or in middle class. So this is going to be pretty low. I'm going to say 20% or something like that. I actually don't know I'm not even going to put that because I actually don't know what the numbers are here. But if you looked at this and you said, oh, well, they didn't complete high school, so they're probably not from a wealthy family. If you did that, then congratulations, you played yourself. Sorry, that's such an old meme to say, but and I called it a meme. So look at how ancient I am. What I did here is I took evidence that I thought I could use here, but I don't actually know. Like, I don't actually know what the rates are of how much does that actually matter for people who come from wealthy families of finishing high school. I actually don't know. It just feels like it should be kind of low, right? And then what about this last one of being a woman? So here, you might look at this and you'll be like, oh, okay, well, I think it's 50%, right? But that's actually not true, right? So it's not actually 50%. It's not equally likely that you picked up a woman versus a guy. Why is it? Why is it not 50%? It's actually 80%. And you knew this, and if you're like me, you chose the wrong answer. And so why is it 80% not 50%, right? Because isn't the natural population, the natural baseline, roughly about 50%? If we're talking in terms of binaries here, but we know that that basically we're talking about a split, right? But you already had this piece of information that 80% of the people that were applying to this job were women, right? So the likelihood that this application right here is a woman is actually 80%, right? So why is it that people will say 50%? Or why will sometimes people will say even lower than that? It's because when we look at this, we feel like we've heard that women are more likely to complete high school, and it doesn't really fit our stereotype of women for them to use a forklift operator license, right? This is why I said it's a problematic example. But this is an example that Kahneman and Tversky developed. So in this case, what we have done is we have ignored the baseline rates in order to try to use this information right here to come up with a better answer, right? So the best answer here is 80%, but most people are going to say that it's significantly less than 80%, even though we were told right off the bat what the baseline rate was for our population. Here is one more example. So let's say that Bob is an opera fan. This is Bob right here. Bob is an opera fan who enjoys touring art museums when on holiday. Growing up, he enjoyed playing chess with family members and friends. Which situation is more likely? Is it that A, Bob plays trumpet for a major symphony orchestra, or B, Bob is a farmer? So which of these do you think is more likely? So think about that for a second, and then you can make your guess. The best answer here, and this is again Kahneman and Tversky's own example, the best answer is B, that Bob is a farmer. But most people are going to choose A. Why do people choose A? It's because when they read about Bob, they're like, oh, Bob sounds like a very sophisticated person. He seems like he's got a great education. It seems like, he likes going to art museums, so he seems very cultured. So it sounds like he would be likely to play trumpet for a major symphony orchestra. But do you know anybody who plays trumpet for a major symphony orchestra? I can't think of any. I don't have any friends that do that. I don't have any family members that do that, right? But what is the likelihood of a random person being a farmer? Is actually quite high, right? Especially for us in Western Mass, where it's mostly more rural than in other parts of the country. But still not very rural compared to like Georgia or Nebraska or whatever. But compared to Eastern Massachusetts, it's very rural. So you probably know some people who are farmers. And so the natural base rate of someone being a farmer is much higher than the natural base rate occurrence of somebody playing trumpet and being in a major symphony orchestra. So in this case, if you chose A, then you have ignored the natural base rates. You think that this evidence, you can use this evidence to further inform your decision so that A seems like the right answer. But there's only so many of these people in America, right, who make their living playing a trumpet for a major symphony orchestra compared to a farmer. So it's very unlikely that A is true, given what we know about the base rates. I'm gonna. I'll talk about this actually, because I cut out a lot of stuff about Bayes and Bayes' theorem and Bayes' probabilities. But when we're talking about Bayes, Bayes is named after Thomas Bayes, who was a theologian slash statistician who did a lot of early work with probabilistic judgments. And then that was kind of adapted later in the 1900s and kind of developed its own kind of statistical field. But basically, the idea here is that whenever we are making any kind of judgment, we should be thinking about the base rates. What are the naturally occurring rates of probability? And then we can look at evidence. But we should look at the evidence and kind of analyze the evidence to think about how useful is this evidence. Does this evidence actually matter? That's something that most of us don't do because of confirmation bias, right? So probabilities are very easy to abstract, but frequencies are easier to visualize. This is part of the reason why people are so bad at statistics. It's much easier for us to make a good decision when we see it. It's much harder to make a decision when we're trying to work from the probabilities. So when information is present, do your best to try to visualize the frequencies of that and do a little bit less of the trying to come up, with the probabilities. So here is a study that basically what they did here is they asked people to guess what is the probability, that you reach into this and that you pull out one of these horizontal lines, for example. What is the likelihood of that, out of 100%? That was one condition. The other condition, they basically had people say, we want you to guess what percentage of these do you think is horizontal? And so the folks looking at this that were trying to assume what is the likelihood, how many of these are horizontal were really, really good at getting the probabilities. Whenever people were asked, just by random, you reach in this and you pull one of these, what is the likelihood of it going to be horizontal? Guesses were way off at that point. So this is one example of why it can be better to visualize your data instead of just trying to imagine it in probabilistic ways. That whenever you're visualizing it and thinking about the frequencies of something, it's more natural for our brain to wrap our heads around that information, to process it, to answer it accurately. This leads us to the Monty Hall problem. The Monty Hall problem is a very famous mathematical conundrum, let's call it. And it irritates people all the time, even whenever you teach this in the classroom. So if you feel like you don't get it, that's okay. Rewind it, start from the beginning and see if that helps. And then if that still doesn't help, just email me. Monty Hall comes from Let's Make a Deal. So the old Let's Make a Deal game was very, very silly, where they would have all these strange kinds of things for its contestants to do. So you got 3 doors here. So door 1, door 2, and door 3. And me, I'm going to be Monty Hall. That was the name of the host. I'm going to be Monty Hall, and I'm going to tell you, you can open up only one of these doors. And behind one of these doors is a bunch of money. And behind 2 of these doors is a billy goat. So do your best. Open the door that you think is going to have the prize behind it. All right. So, and that goat is $100,000. So you could buy 3 textbooks with that prize. So we got these 3 doors. But before you open this door, you choose door number 3. And then I say, okay, before you open this door, I'm going to open up one of these other ones. So I'm going to open up door number 2. And door number 2 is this billy goat. So now you got door number 1, door number 3. And then I tell you, do you want to stick with door number 3 or do you want to switch over to door number 1? What would you choose? Almost everybody chooses to stick with number 3. People are going to stick with this door. It's not a good idea, though. Why not? And this is where people get irritated. Because whenever I say that, you're looking at this, because I already know, because like I said, I'm good at predicting your behavior because I'm a psychologist and I'm a scientist, so one of my goals is to predict your behavior. Why do you think you want to stick with number 3? Because you think that it's only 50 versus 50, right? That at this point, you might as well be guessing, and if that's the case, just go with your gut. Just go with the first one, right? That's the logic that you use. It's bad logic. You shouldn't do that. So why is that? Here is why. And you're not going to find this explanation to be satisfactory, but that's okay. Because right now, we're just thinking in terms of probabilities. I'm going to give you another example where we think about this in terms of frequencies, and it might change the way you think about this. So here, we have 1/3 of a chance of choosing the correct door, right? So it's 1 out of 3. When we choose one of these, now our gut tells us that it is 50-50. That is not true. It is no longer 50-50. What happens is that, think of it this way, that behind one of these doors is a bunch of money, right? It's $100,000. And we have a 1/3 chance of choosing that. But for these other doors, we actually have a 2/3 chance of getting a goat. And not a good goat. Not like this. We're not talking about capital G, capital O, capital A, capital T. We're talking about regular goat. Barnyard goat. So, we have so the odds are against us at first, right? So by eliminating one of these, it doesn't revert it to 50-50. What happens is that it's still a 2/3 likelihood that you are going to choose the incorrect door. But you've already had one of these chosen for you. So it's actually in your best interest to now switch over to this one, to the first door. And again, you may be saying, wait a second, I still don't get it. Let me show you. All right, so let's visualize this now. Let's make this extreme. So now you have a bunch of doors, right? So we got all these doors, and you don't know how long it took me to make this. So let's say that the same idea, where we have 100 doors. One of these doors is going to have a bunch of money. The other one's going to have a bunch of billy goats. I'm going to choose this door, and then, you're going to choose this door, and then I'm going to say, wait a second, before you open up that door, you can open up, I'm going to open up all these doors. They all have billy goats, and I'm not going to open up this one. Now, what do? Do you go with this door over here, or do you stay with this one? Some of you may still be saying, I'm going to stick with this one because it's still 50%. But it's not 50%. Because, think about it like this. If you chose any other door, right? If you chose any other door, you know that door is going to stay shut. And that there's only going to be one other door that's also going to stay shut. And all the other ones is going to stay closed. So if, for example, if this is actually the real door, and you chose this one instead, then all of these others should open up, and if that one doesn't open up, then boom, you're probably right, that was going to be the right door. But what happens is that once we choose this door and we open up all of these others, then basically the likelihood that this one has the money exponentially goes up. It's far more likely that this one has the original, because what we're looking at, if this is 1 out of 100, then we're saying that you have a 1 out of 100 likelihood of choosing the right door, and that now, and so all of these are initially 1 out of 100, 1 out of 100, 1 out of 100. But when I roll all these other ones out, all of this percentage is now going to go over to this. So now this one is 99% likely to be correct. And this one is still 1 out of 100. So next time you're on Let's Make a Deal, think about it. That it's very unlikely for you to choose the briefcase correctly from the get-go. All right. So in this case, the best choice is actually to switch, but most people are going to stay and to not switch. The interesting thing here is that humans get this wrong. If you do the same kind of test for animals, and they've done this kind of test, but with food instead of money and goats, non-humans don't do this. Non-humans learn very quickly that they should switch the strategy, but people don't really do that. It's interesting stuff. All right, so now's a good time to pause, and we're going to cut back and talk about heuristics next. All right, so I'm going to take a sip of this iced coffee. All right, and so this is also a very long chapter. So usually this one takes like 2 full weeks of class time to cover. So this is why it's a little bit longer than some of the other ones we've talked about. All right. So let's talk about heuristics. Heuristics are going to be shortcuts that we take whenever we are trying to make decisions. And again, most of these are going to be good shortcuts. It's just that we don't really notice them whenever they do the right thing. We notice them when they do the wrong thing. So the example that I gave where we were ignoring the base rates, and that led you to think that it was 50% likely to be a woman instead of 80%, that is an example of heuristics gone wrong, right? But most of the decisions that we make, like what do you get for breakfast, are you going to use your debit card at the gas pump or cash, these everyday kind of decisions, you're probably going to use a lot of heuristic to do that because you don't have to really think about it. Then you can let system 1, that really fast system of your thinking, handle all of these things and you don't have to worry about it. So heuristics are, on the whole, usually pretty good. They usually give us the right answer. But we're going to highlight some examples where they give us the incorrect decision as a way of highlighting what those heuristics do. We're going to do the same thing next chapter when we talk about problem solving. We're going to be talking about why we're bad at problem solving as a way of showing how problem solving normally works. So here we're going to be talking about the representativeness heuristic, and you'll see that it's very, very similar to base rate neglect. So when we are trying to imagine how likely something is, we are going to compare it to our pre-existing knowledge for that information. So in the previous example where you're thinking about a forklift operator and how likely they are to be a woman or a guy, you're using maybe some pre-established traditional gender norms in order to do that. You're thinking like, okay, well, women typically don't work using forklifts. That's typically more of a masculine type of thing, and so I'm going to say that it's unlikely for this person who has a forklift license to be a woman. That, as we saw, is not good reasoning, right? But that is somebody using their pre-existing knowledge of how they think the world works to make an informed decision, or in this case, a misinformed decision. So this is very closely related to prototype theory, which we talked about earlier in Chapter 9. And when we are trying to make a decision about how likely we find something to be, we usually will think of like a prototype and then make judgments based on that. So for example, if I told you that I was a teacher, and this happens all the time, when people ask what I do for a living, I tell them a teacher. I don't tell them a professor because it's none of their business. Usually, but I usually tell them that I'm a teacher because it's easier to have a conversation with somebody if they think you're a teacher. If you tell them they're a professor, they're going to ask you a bunch of questions, and I don't want that in my life. So I usually tell folks that I'm a teacher. And usually they will assume that I teach high school. And that's because the prototype of a high school teacher is more, or actually let me reverse that. It's because people don't guess elementary school. They don't guess middle school. They don't guess pre-K, because if you're guessing pre-K and you're guessing a preschool teacher, the first image that pops into most people's heads is not going to be a guy. It's probably going to be not a guy, right? It's probably going to be a woman, because that is the stereotypical kind of gender norms in our society, right? It's easier for you to think of examples. Maybe your preschool teacher was a woman, and that's why that prototype is more feminine in nature. So that is an example of how prototype theory is involved in this kind of base rate neglect and why we make bad decisions here. Same thing is true, by the way, for professors. That so my wife is also a professor. If she were to tell people that she was a teacher, they're going to assume that she probably teaches elementary school or middle school. In that case, when in fact she is a professor. All right. So, and I don't want to talk about this too much because I don't want to get too involved in math here. But this is another example of how our decisions can be bad when we think we have more information. That just because we have more information doesn't necessarily mean it's a good thing. Because when we're talking about probabilities, it's important to remember that the likelihood of one thing occurring is always going to be greater than the likelihood of that one thing occurring and something else happening. So, what I mean here is that what is the likelihood of X versus what is the likelihood of X and Y happening together. The likelihood of X happening alone period, is always going to be, just based on mathematical properties and laws, as likely or more likely than whenever both of these are combined. So, and here is an example of this. Let's just say that I'm thinking off the top of my head here. What is the likelihood that somebody is... Oh, okay, so thinking about in terms of our classroom. Ooh. Yeah, I was going to give you an example about myself, but I'm not. I'm going to give you an example of a fake person. So let's say there's a random person in our classroom, and you thinking about, it's cognitive psychology. All right, what is the likelihood that this person is a junior versus that they are a senior and a psych major? So, which do you think is likely? If I were to pick a random student in this classroom, what is the likelihood of them being a junior or likelihood of them being a senior and psych major? Which one of these would you choose? The best answer, the ideal answer, is to go with this one, just as a junior. But why? It feels right to include psych major here. Why isn't that correct? Let's just say, for the sake of argument, because we do have a lot of juniors and a lot of seniors in here, but let's just say that it's evenly split between, we got 25% freshman, 25% sophomore, 25% junior, and so on. So we got 25%. What is the likelihood of anybody randomly being a psych major? Let's just say, for the sake of argument, that it's 100%. Let's just say, for the sake of argument, that's 100%. That everybody in this class is a psych major. So in this case, these are equally likely, right? That junior and that. But if we were to tweak this at all and say, okay, it's 95% that they're a psych major. If that's the case, then it's more likely that they are a junior. Because when we take 25% and multiply it by 95%, we're going to get something like 23%, right? Instead of 25%. So by having these two personality traits combined, now we're more likely to be wrong than if we were less specific. So being more specific is not always good in this case. So here is an example from Kahneman and Tversky they came up with. So 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with the issues of discrimination and social justice, and she also participated in anti-nuclear demonstrations. So what is, in this case, they asked people, is Linda a bank teller, or is Linda a bank teller and is active in the feminist movement? That's how you know this is a dated example that Kahneman and Tversky used, because it was like in the 70s whenever people would talk about being active in the feminist movement. Now people are feminists, and you don't have to be in the feminist movement, right? So people were more likely to put these two together and say Linda was a bank teller and is active in the feminist movement, instead of just saying Linda is a bank teller or Linda is active in the feminist movement. By combining these together, it feels like we're being more specific, but in fact, we're getting less probable now. If we apply the same logic here, let's say the likelihood of somebody being a bank teller is 10%, and the likelihood of somebody being active in the feminist movement is 30%. So the best argument would be to say that Linda's active in the feminist movement, right? And that's it. Because if you say both now, then we're doing 10% of 30, which is 3%, right? That's not good. So it's very unlikely for her to be both of these things at once. But it feels more correct to do that. All right, so moving back to the representativeness heuristic, I'm going to give you another example, and this is one that I usually actually make kind of interactive in the classroom to try to replicate this experiment. It would be too confusing to this online, so I'll kind of walk you through it though. There were 3 groups in this study. This is called the Tom W experiment. Very important experiment in decision making. Basically, Kahneman and Tversky are going to ask people a couple of questions. So for group number 1, they're going to say, we want you to consider all first-year graduate students in the United States. What is your best guess about the percentage of students that are currently enrolled in? And then they give them these 9 fields: business administration, computer science, engineering, humanities, education, law, library science, medicine, physical and life sciences, and social science, social work. If you would like to, you can do this at home. I feel very confident this will work on you, and it'll prove that you make bad decisions if you try to follow along. I have a hunch about that, because it's a very tricky experiment. You might think you know the answer. So here, what I want you to do is just say, like, all right, business administration, that's probably pretty common. I'm going to say 30%. Computer science, not so common, 10%. Engineering, not so common, 10%. Humanities and education, that's pretty common, just 30%. And just, don't use those numbers. Those are my numbers, and you can't plagiarize my numbers. But I want you to just come up with what you think are some baseline, or if you want to, just rank them. Rank them in terms of which one do you think is the most popular and which one do you think is the least popular. Okay, when you lock those numbers in, meet me on the next slide. So, groups 2 and 3 got this information right here. Tom W. is of high intelligence, although lacking in true creativity. He has a need for order and clarity, and for neat and tidy systems in which every detail finds its appropriate place. His writing is rather dull and mechanical, occasionally enlivened by somewhat corny puns and by flashes of imagination of the sci-fi type. He has a strong drive for competence. He seems to feel little sympathy for other people and does not enjoy interacting with others. Self-centered, he nonetheless has a deep moral sense. So group 2 were asked, how similar is Tom W. compared to the typical student in these 9 fields? And so they had these individuals basically go through and say, like, all right, I think he's number 1 in this one, and that he's second most likely to be in this one, and that he's 9th most likely to be in this one. He's least likely to be in this one. Group 3 were told that the description you just read was a description written by the school psychologist based on tests that they had done. So what do you think is the likelihood that Tom W. is currently enrolled in one of these? And again, you can do a ranking. Okay, so what does this mean about our ability to make decisions? So Group 3's rates were much, in the original study here, Group 3's rates were much closer to Group 2's than to Group 1's, and that is very, very important. Why is that important? Because Group 1 established the baseline. Group 1 established what the natural, rates of probabilities are for this. So if you did this, I want you to keep in mind which ones you had for your top 3 and which ones you had for your bottom 3. Because you should, if you were using perfect, logical, rational decision making, you already know the base rate of occurrences here. You should take those same rates and apply those to Group 2, where you would basically say that Group 2, actually, forget that. For Group 3, you should say what is the likelihood of Tom W. being enrolled in one of those. It should be the same top 3 you listed for Group 1 and the same bottom 3 that you listed for Group 1, because you're looking at how likely is he going to be in these, and you already know the natural rates of occurrence. But most people are going to be more likely to do Group 2's rankings, where they're probably going to say something like, because what they usually will say is that Tom W. is more likely to be in computer science, engineering. Actually, let me circle these. And I'm going to say library science. No, I'm going to say medicine. No, I'm going to go back to library science. So that he's most likely to be in one of these 3. And that he's least likely to be in humanities and education, social science, and the other one, I don't know. I'm going to put medicine here because I don't see him interacting with other people really all that much. But what we probably should have said if we were following the base rates is that he is probably going to be in business administration, he's probably going to be in humanities and education, and he's probably going to be in the social sciences, or I don't know whatever you chose as the number 3 most likely or most popular fields of study. But that is an example of base rate neglect and of what they call the representativeness heuristic, where we formed an idea of who Tom W. was, and then we tried to find, using that evidence, what we think, we tried to make decisions based on what we thought about that individual and how much he applied to how much he represented these other options. That's not logical, though, right? If we wanted to be most accurate, we would try to follow along with whatever our group 1 base rates would be. All right, this is a great time for me to take a pause. I'm going to cut the video short here because we got probably another 40 minutes, and I don't want to go on for another 40 minutes. I'm going to cut this video here, and then we can resume video number 2 later on. So thank you so much for tuning in for an hour, and I will see you for the exciting conclusion of the decision-making chapter later.